So doing questions like this now are a piece of cake. But make sure you watch out for specific things. Look for multiplicities, look for degree, look for leading coefficients. So let's do this. Okay, here we go. Leading coefficient is negative, which means then that this end tendency is downwards on the right-hand side. Okay, this has a multiplicity of 2, which means it's going to be a U-shaped. This has a multiplicity of 1, that has a multiplicity of 1, which just means it's just going to cut the axis. Okay, so let's figure out what the zeros are. The zeros in this case is going to be -2, it's going to be +1, and +3. Beautiful. Okay, so -2, 1, 2, one of the zeros, and that's where the multiplicity is going to be. +1, there's another one, and 2, 3, there it is. There's the third one. Now, here's the other thing that you have to be interested in, okay? Let's take a look at the idea here of this negative. So that means that this guy's got to have an end tendency down here. But I'm also wondering, what is the degree of this polynomial? Well, being that this is squared, it's got 2 here. There's a multiplicity of 2. That's a multiplicity of 1. That's another multiplicity of 1. So this is a degree 4. So whenever it's an even degree, don't forget that you're going to both be pointing down or both be pointing up. Interesting. Okay. Now, let's go out and graph this thing and let's see what we get. So before we graph this thing, let's just plan this out. At x minus 2, this should be, I would think, a bend here like this because it's a multiplicity that is even. Then it should come down here, probably come up here, bend around again, and do something like that in order to hit all 3 of these points. So I'm actually going to have, a y-intercept out here. I wonder what that y-intercept is. Remember that y-intercept happens when x equals to 0. So check this out. I'm going to make this a 0. I'm going to make this a 0. I'm going to make this a 0. Wait a second. Doesn't that leave me with 2 squared? Well, 2 squared is 4. Isn't that a -1? Okay, so that's a -1. And isn't that a -3, which is going to give me a -3, plus I have this negative up front. Okay, so, well, let's figure it out. -4 times -1 is a +4. 4 times -3, I have a prediction that my y-intercept is going to be right down here at -12. That's my prediction. Okay, so let's go throw this in the calculator and see how accurate I am. There's my calculator, and oh my goodness, there it is all ready for us. I'm curious, is this thing actually here -12 as we predicted? Well, how can we find that out? Well, simple. Go second calc, okay, find me the value. Well, the value of what? Well, when x is 0. That's x is 0 gives you a y-intercept, doesn't it? Oh my God, yeah, I was right. Whew, I love it when I'm right. Okay, let's find out some other stuff here as we go. Let's answer the question. So, write the window settings. Well, guess what? I use the same window settings. I haven't changed it since the last time. So let's go to the window settings here. What about, there's -10, +10, -30, +30, all of them beautiful, just like that. Okay, so let's write that down. For the x, -10, +10, going up by an interval of 1. For the y, I'm going from -30 to +30. I'm also going up for an interval of 1. Let's put our descriptions down here. Let's put down all of the zeros. Remember the zeros were -2, 1, and 3. -2, 1, and 3. At -2, we had a multiplicity of 2. We had a U-shape. Okay. At 1, we had a multiplicity of 1 and a multiplicity of 1. We know that it just cuts through. Right? No bending here at all. Okay, cool. Let's answer the rest of the question. Degree of the polynomial matches the multiplicity, right? 2, 3, 4. Boom. Boom. Look how easy this is. Using technology, let's find the minimum of the function again. Oh, okay. Well, why don't we find the minimum and the maximum of this? Because after all, look at the way it bends. So we can find this minimum down here, which could be, it's pretty close to the intercept. So I'm going to predict it to be about -12.5, maybe -13. And then let's find this maximum right up here. Okay, second calc, here we go. Find me the minimum, which is 3. Now remember, these are local minimums, okay? They're not actual minimums because of the fact this continues on in that direction forever and ever. Amen. So left bound, enter. Right bound, okay. Enter. Guess, of course, minus 0.22 and minus 12.4, which we kind of predicted around minus 12. Let's find the maximum. Second calc, let's find the maximum, which is 4. Same as always. Enter here, right bound and left bound, or left bound and right bound. Enter. Here we go. Take a guess. And look at that. We got it at 2.22 and 16.9. Wow. Cool stuff. Answer the rest of the questions that go along with this. Okay. Where's the y-intercept? Well, I predicted the y-intercept and I was right. It is, in fact, at minus 12. Maybe put a star down here that you can, of course, use second calc, right? Calc. And then you can use the idea of value. And you can put down that x equals to 0 because, of course, our y-intercept works that way. All right. Anything else to answer on this? Nope. So let's call this a podcast and let's go on to the next thing. Here we go.